In this video, we will be introduced to the normal model and the 68, 95, 99.7 rule. In a previous video, we learned that a z-score is the number of standard deviations a value is away from a mean. We also learned previously that to calculate the z-score, we use the formula z equals x minus the mean of the sample divided by the standard deviation of the sample. We will be using z-scores as we work with the normal model. Let's say we make a histogram using given data. If our data is symmetric, unimodal, and the distribution is bell-shaped, the data is said to be normally distributed. For normally distributed data, we use a model called the normal model to determine the portion of values that lie within specific ranges. With normally distributed data, most of our values will lie between 3 standard deviations below the mean and 3 standard deviations above the mean. The model goes into even more detail, telling us that 68% of the values are within 1 standard deviation of the mean. In other words, 68% of the values have a z-score between -1 and 1. 95% of the values are within 2 standard deviations of the mean. In other words, 95% of the values have a z-score between -2 and 2. 99.7% of the values are within 3 standard deviations of the mean. In other words, 99.7% of the values have a z-score between -3 and 3. Let's take a look at how we can use this information in an application. If the mean SAT math score is 500 and the standard deviation is 100, how unique is a student who gets 740 on the math SAT? To answer this question, we have to start by finding the z-score. Z is equal to the SAT score minus the mean over the standard deviation. 740 minus 500 over 100. Z is equal to 2.4. We look for the z-score of 2.4 on the x-axis. 99.7% of values are within 3 standard deviations of the mean, and 95% of values are within 2 standard deviations of the mean. If we subtract these percents, we get the percent of values between 2 and 3 standard deviations from the mean. But a half of these values are below the mean and a half of these values are above the mean. We divide by 2 and find that 2.35% of values are between 2 and 3 standard deviations above the mean. This tells us that a student who gets a score of 740 is unique, as only 2.35% of students fall in that range. Here's a summary of what we've learned. The normal model can be used on symmetric, unimodal data that is bell-shaped. Normally distributed data follows the 68, 95, 99.7 rule. On normally distributed data, we can use the z-score to determine how a value compares to other values in the data set.